All right, so on 9.4, binomial expansion. What binomial expansion is going to allow us to do, let's do a thing. Here we have like x plus y to the 0, x plus y to the first, x plus y squared. Let's think, if I had to do x plus y squared out, what would I have to do? What would I have to do x plus y squared? What would I have to do, guys? If I wanted to expand it out. X plus y times x plus y. And then I have to do what here? What does this mean? Distribute. FOIL. FOIL. Multiplying two binomials with FOIL. First, x squared. Outers are going to be xy. Inners are going to be xy. So I get 2xy less, I get y squared. Okay? You guys are probably, for this lesson, you guys are probably going to want to write this in your notebook, not your calculator, because this is going to get long in a second. Or you're still typing in your calculator. All right. So, knowing that, x plus y cubed is really what? X plus y, x plus y, x plus y. So if I want to do this out, I would have to say, okay, well, I'm going to start with these two. I know these are x squared plus 2xy plus y squared, because I just did that. Then I have to multiply by another x plus y. And now, does anybody remember how you do this? No, that's what you were saying before. I'd have to distribute the x, I'd have to distribute the y. I'd have a bunch of like terms to combine. It gets really long, it gets really ugly. Nobody wants to do it. The easy way, bear with me because it's not going to look like the easy way at first. The easy way is using this. We call this the binomial expansion. This is on your reference sheets. You do not need to memorize this. It's on your reference sheet. You probably want to take out your reference sheet so you can do some of these problems without me flipping back to this. On your reference sheet. So this is saying that if I have a binomial, x plus y, and I'm raising it to the nth power, I can go, see, n c 0. So n is the exponent. That's always going to be the first part in each combination. X, whatever my first thing is going to go here. It's going to start, and keep in mind, when I had like x plus y squared, the first term was x squared, right? It's always going to start to the n, and then it's going to keep going down by 1. The second term, the y in this case, starts at 0. Exponent is 0, so it's just 1. It goes away. That's why I don't write it. And then it keeps going up by 1. And then these combinations are basically going to give you your coefficients. Your coefficients, just like the y values, they start at 0 and they end at n. Okay, so I know it's a little bit confusing. When you see it applied, it'll be a little different. So we have 2x minus 1 to the fourth. Okay, we want to expand it out. We're going to use our formula. What's going to be for my first term in my formula? Okay. What are we gonna put in there for my combination? What are we going to put in for my combination? Look at the formula on the reference sheet. 4c what? 4c0. 4c0. 4 is my exponent, my n. So that's going to go there. I always start at 0. What is the term that's in the x position? So this is like saying that this is x and this is y. You could say 2x minus 1 to the fourth equals this, because we're, yeah. X plus y is the general. So what am I going to put in here for my next position? I put in the 2x. I put in whatever in the front term. What am I going to raise the 2x to? The fourth. I always start at my n. My n is 4. Just like I said, with x squared, I started with x squared, then I worked my way down. What do I put in for my y? -1. The formula is written with a plus, so if we see a minus, that means it's a negative. What's my exponent here? -1, not -y. My exponent is 0. What's my second term? 4c1, exactly. Now, just like in binomial, do you see how this is essentially a binomial distribution? It's got the combination, something to the something, something to the something, right? What didn't change when I was doing that? When I had like 2 of them, where the probabilities were didn't change, right? Yeah. So this is going to be the same. 2x. This time, what am I raising it to? The third. Yep. What am I going to raise -1 to? First. They still add up to the 4. But the only kind of real difference is that this number and this number are no longer going to be the same. They're going to change. That's only in this. What's my next combination, John? What do we got? 4c2, and then I'm going to have 2x to the second and -1 to the what? Second. Yep, I know it's sometimes it's tough to keep these on one line, especially when you're not used to doing them. But they're going to get shorter than this in a second. Keep going, we get 4c3 to the third. Say first or third? First, yeah, it's the first. First, and -1 to the third. My last one, 4c4, 2x to the 0. Perfect. -1 to the fourth. Okay, now if we simplify this, we're actually just going to get a nice expression that we wanted. What is 4c0? What is 4c0? Do it in your calculator. It's 1, okay. What's 2x to the fourth? You can't do this in your calculator, it's got an x. What is it? You gotta remember your exponent rules. 2x to the fourth. 16x to the fourth. It's kind of like distributing the exponent. When you have all multiplication, you distribute the exponent. You can't distribute the exponent over addition, but you can over multiplication. So 2 to the fourth is 16, x to the fourth. This was 1. Okay, what's -1 to the 0? What is anything to the 0 power? 1. It's 1. So this is 1, this is 1. I don't have to write those. 4x to the third, or 4x to the first, sorry. 4x to the first is what? 4c1. 4. Yep. 2x cubed is? What's 2 cubed? What's 2 cubed? 8. What's x cubed? It's -1 to the first. -1. Any number to the first is itself. This is -1. 4c2. 4c2. 6, 2x squared. Negative 1 squared. Negative 1 squared. Come on, guys. Killing me. Negative 1. Negative 1. Positive 1. Negative 1 times negative 1 is a positive 1. If you didn't put your parentheses in like this, calculator would be giving you negative 1. You gotta be careful. So I'm not going to write that. 4c3. 2x to the first. 2x to the first. How did that happen? And negative 1 to the fourth. What is it? 1, positive 1. So I'm not going to write it. So all you got to do now is just clean this up a little bit. 16x to the fourth. I skip over 1. Oh, this one right here, I did it. Oh, I did skip it, you're right. Okay, yeah. So what is it? The one I skipped. 4c3 I skipped, right? Or 4c2. Oh, yeah, this is a negative 1. This 4 came from 4c3. This is 2x to the first. I need negative 1 to the third. Is negative 1. Okay, yeah, and I skipped the last one. Sorry. What's 4c4? 1. I'm not going to write it. 2x to the 0? 1. Anything to the 0 power is always 1. Anything to the 0 power is always 1. What is negative 1 to the fourth? Positive 1. Okay? So each of these, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We can simplify this a little bit. We have a negative 32 x cubed. Okay? Multiply here, we get 24 x squared. Just cleaning up my notation a little bit. Plus 24x squared, yep. And over here we have what? We have what? Minus 8x, perfect. Plus 1. So our answer is 16x to the fourth plus 32x cubed, or minus 32x cubed, minus 32x cubed. Plus 24x squared, minus 8x, plus 1. Okay? I know that seemed like a lot of work. However, most of the time, does everybody have this down? Most of the time, they're not going to ask us to expand the whole thing. Most of the time, they're just going to ask us to do one term out. Okay? So think about here. What's the third term for this thing? For this, what is it? 2x plus 2y is 6, okay? The way we figure out the term, what term number is this? What term number is this? The third term. But we always start counting our terms with 0. Remember how it went like NC0, NC1, NC2? So we count our term number 0, 1, 2 for the third term. Okay? Now, the other question you have to ask yourself is what exponent will the first one have? We're just gonna determine which one we need, and we're only gonna do one. So what exponent is the 0 term, the first term, the 0 term, gonna have on the x? A 6. Why 6? Yeah. It always starts with the top number. Okay? It always starts with the end, and then it's gonna work down. So the first one's gonna have a 6. What's the second one gonna have? And the one we're looking for, the third term? There we go. So to set up our, yeah, basically. So if we set up our combination in our binomial expansion term, what are we going to have? Look on your formula. Okay, 6. It will be 6. Why would it be 6? It's raised to the 6 right here. This is always our n. Careful with the 6c3. Not 66. Not 6c2. Why 6c2? You count the terms starting from term 0. So term 0, term 1, term 2 is our third term. The 6? Right here. What is the thing in my x position? 3x. And I'm going to raise it to the 4th power. Perfect. We want the term where the x is going to be at the 4th power. That's what this is, the exponent. What's in my y position? 2y. Raise it to the what? 2nd power. Because these still need to add up like this. It's still a binomial. So what is 6c2? Six? I said, what is 6c2? You put in the calculator, you get 15. Okay. 3x to the 4th is what? 81x to the 4th. Remember, exponents don't mean multiply. They mean multiply 3 times 3 times 3 times 3. And 2y is? 2y squared is? Yeah, 4y squared. So if I clean this up a little bit for notation, I would have to multiply all my coefficients, right? 15 times 81 times 4 is what? Yep. X to the 4th, y squared. That's our third term of that written in standard form. So the big thing to keep in mind when they ask you for a specific term, count out start with your terms, count 0, 1, 2. So I always start with one less than that kind of. If you want the third term, you're going to use a 2 here. And for your exponent, you're going to count backwards from here. So like 6, 5, 4. 6, 5, 4. Okay, and that's how you get this starting point. All right? Your homework is going to be pages 16 and 17. Make sure you omit number 5. There's not that many. We're going to go over a little bit more on this tomorrow, too. Don't worry. So omit number 5 on the homework, pages 16 and 17. Well, then we might as well do another example. Give this one a shot. What is the middle term of 2x minus 3 to the 8th? So there's 8 terms. What are the terms going to have as far as they go? What are we looking at here? What are you counting? What are you counting? Huh? So yeah, we start from 0. 0 is our first term, and then term 1. Six up. Careful. To the 8th. This is our first term. This is our second term. This is our third term. 4th, 5th, 6th, 7th, 8th. There's only terms 0 to 7 mean there are 8 terms. Okay? It's always one less. So which one is the middle term? We are the middle term. Why did I do this? Oh, yeah. Oh, you know what? There are actually 8. I'm thinking about it. It does go to 8, right? Or no? It goes to 8. Yeah. Yeah, it goes up to there. Yeah. So 4 is the middle term. There are 9 terms when you're raising to the 8th, because there's that constant. When you're raising to the 9, there's 10 terms in the equation. Well, it's less when you're talking about the third. The way the word is weird. Because here it says middle term, so we're looking for something different. 4 is our middle term. What is my combination going to be? 8C4. Perfect. 8C4. We have an exponent of 8, and we're going to raise it. We are looking for what is essentially the 5th term, but it's number 4. Two x, that's in our x spot. And what are we going to raise it to? The 4th. How did you figure out we're raising it to the 4th? Yeah, what's the exponent? This is where you have to do another kind of thing like this, or count backwards or something. What are we starting with? What's x going to be in the original, in term 0? What's the exponent of x going to be? 8. It always starts out here. So 8 in this one, 7, 6, 5, 4. So the exponent that we're looking for is the 4th. Okay, this happens to be a coincidence that these work out this time. Well, it goes in my y spot. To the 4th. Why this time to the 4th? They have to add up to 8 still. Okay? What is 8C4? What is it, 78? Yeah. 70? 70, yeah. What is 2x to the 4th? 16x to the 4th, yes. And negative 3 to the 4th? Negative 3 to the 4th? Positive 81. Make sure you watch your parentheses. So when you do out your simplification, we're going to multiply these. 70 times 16 times 81 is what? 90,720. X to the 4th is our answer. Okay. So let's try. Go to the next one. We got a little bit of time. What is the exponent of x in a second term? Just set it up. Just set it up right now. Well, we can do it as a group. We don't have time enough to do it individual. What term am I looking for first off? Term number what? I'm looking for the second term. So if I start at 0, my second term is 1. So what's my combination going to be? I was going to see. So what's it going to be? It's going to start with 4. You're always starting with just the exponent. 4C1. We counted, it's the first term. Okay? What goes here? What's in my x spot? X squared. What exponent do I want that to be? It's the second term. It's the second term, right? So what's the first term going to have? The first term is always going to start with this. A 4. So the next one's going to start with a. Yep. Now don't get confused with this x squared. That's kind of irrelevant. The fact that there's a squared in there and it's going to change. We're just looking at the big picture of the binomial. And the first one's going to have a 4, and then we're going to have 3. What goes here? Negative 1 over x, perfect. We're going to raise it to the what? There you go. We could simplify that out through the multiplication and simplify. You can do that on your own. But this is the key. They say second term, you count out 1, 2, but it start out 0 and then 1. Then you think, what's your exponent on your x? You're going to go 4. You start with 4 because it's right here. And then 3 is your next one. Okay? That's the key to setting these up.